everybody. In today's discussion, we will discuss on the derivation of the Bernoulli's equation from Euler's equation. So in the previous class, we derived the Euler's equation for three-dimensional Cartesian coordinates. Once Euler's equation is derived, integration of Euler's equation gives Bernoulli's equation. How that is done, how finally we obtain the Bernoulli's equation, that we discuss in today's class. Apart from that, what is the importance of each term of the Bernoulli's equation? Because you know that the three fundamental equations of fluid mechanics, one continuity equation and the second one is Bernoulli's equation. So continuity equation we dealt in fluid kinematics, and now we are taking up the second one in this fluid dynamics. So straight away, let us go into the sharing part, and then let us go to the whiteboard. So first, before starting the derivation, let us take Euler's equation. Euler's equations of motion. X minus 1 by rho dou p by dou x is equal to ax, and ax is equal to, we know, it is u dou u by dou x plus v dou u by dou y plus w dou u by dou z plus dou u by dou t. Same is the case in y direction. 1 by rho dou p by dou y is equal to ay is equal to u into dou v by dou x plus v into dou v by dou y plus w into dou v by dou z plus dou v by dou t. Similarly, z minus 1 by rho dou p by dou z is equal to az is equal to u into dou w by dou x plus v into dou w by dou y plus w into dou w by dou z plus dou w by dou t. So next what we mention, integration of Euler's equation gives Bernoulli's equation. And we are working on that. Now, before going for that integration, now if you see the equations, x one term, 1 by rho dou p by dou x one term, right hand side u dou u by dou x, v dou u by dou y, w dou u by dou z, dou u by dou t. So if you see the entire equation except x, all others are in differential forms. So if you can get x also in terms of a differential form, then integration will become easy. So that's why the first step what we are doing is, there exists, this is only we are telling, there exists a force potential which is denoted by such that its negative derivative in any direction gives the gravity force component per unit mass in that direction. This is only which we are mentioning to see that this x also is represented in terms of a differential. So what it indicates, x is equal to minus dou of force potential by dou x. Similarly, y is equal to minus of dou force potential by dou y. And z is equal to minus of dou force potential by dou z. This is purely made only from the angle that we want to represent x, y, z also in terms of a differentialing. Now, if we take this as first, then second, the second one, what we are doing, if you see again the equations, the first term now x is equal to minus of dou force potential by dou x we can write. Then this also in term with respect to x. Here this also with respect to x. But here if you see v into dou u by dou y, w into dou u by dou z, dou u by dou t. So these three, if you observe it, they are in the actually the derivatives. If you see dou u by dou y, dou u by dou z. So what we have to do is this dou u by dou y and dou u by dou z also should be represented in terms of actually some what we call it as x. So how to do that actually? So if otherwise, if you see this is minus dou force potential by dou x, this is x. Here is also x. Here and here also x should come. How should we do that? That is the next challenge actually. So now that also how I want to do it. Here it is u dou u by dou x. Here I want to do it in such a way it should be v into dou v by dou x, w into actually dou w by dou x. That is what I want to get it. How to get that, I will explain. To get that, actually, we assume that the flow is irrotational. Flow is irrotational means the rotation is zero. Rotation about z-axis is 0, rotation about y-axis is 0, rotation about x-axis is 0. Even if you don't remember that basically these rotation components, kindly remember that what we want to change is dou u by dou z, we want to replace actually with dou v by dou x. And similarly, basically dou u by the second dou u by dou y, dou u by dou y, sorry, dou u by dou y, we want to replace it by dou v by dou x. Similarly, dou u by dou z, we want to replace by dou w by dou x. Why? Because all the denominators, if they are with respect to x, then integration is simple. Let us start from mathematical point of view rather than physical definition. So my objective is that v dou u by dou y should be v dou v by dou x. Similarly, w dou u by dou z is equal to w dou w by dou x. How that I can make it is, this is the assumption. Flow is irrotational, so rotation is 0. What is that rotation? If I take it, rotation about z axis is equal to half into basic. You don't need to think so much actually. From here itself, you can write it. It is dou v by dou x minus dou u by dou y is equal to 0, the first one. Similarly, if you want to see rotation about y-axis, half into basically it is dou w by dou x minus dou u by dou z is equal to 0. Therefore, dou v by dou x is equal to dou u by dou y, and dou w by dou x is equal to dou u by dou z. Now, if you represent, this is the second thing. Then third point is the moment you are taking it, this basically, if you are assuming the flow is irrotational, automatically the velocity potential exists. So when the velocity potential exists, then that means phi exists because the flow is irrotational. So therefore, what I can write it is the last dou u by dou t is equal to dou by dou t of u is equal to minus dou phi by dou x. It is nothing but actually minus dou square phi by, basically we can write dou x dou t. So now if you see left hand side, x also is written in terms of differential with respect to x. The right hand side, all I have made it with respect to x. So now if I take it the first, now considering the now considering the Euler's equation in x direction. So it is x minus 1 by rho dou p by dou x is equal to u dou u by dou x plus v dou u by dou y plus w dou u by dou z plus dou u by dou t. Now you see how I am changing. X I am making it as minus dou sigma by dou x minus 1 by rho dou p by dou x u into dou u by dou x. That dou u by dou y I am changing v into dou v by dou x plus w into dou v by dou w by dou x plus dou minus dou square phi by dou x dou t. This is what we are getting actually. Again, if I a little bit, I will move. So it is minus dou sigma by dou x minus 1 by rho dou p by dou x. So this I can write half of dou by dou x of u square plus half of dou by dou x of v square plus half of dou by dou x of w square minus dou square phi by dou x dou t. This is the equation. Again, I can simplify minus dou into sigma into x minus 1 by rho dou p by dou x is equal to half into dou by dou x of u square plus v square plus w square minus dou square phi by dou x dou t. If now I take common, basically, for example, this all, if I take it all to one side, if I take it and take basically either take this to that side, and now if I take dou by dou x of, if I take everything onto one side and equate to zero, then naturally it becomes now integrating. It is when integrating with respect to x, it is yz. Now u square plus v square by plus w square basically square is by 2 is equal to, it is nothing but if I do it, p by rho plus v square by 2 minus dou phi by dou t is equal to f of yz. Similarly, if you do other equations also, if other equations, other Euler's equations are integrated, we get the same equation like p by rho plus v square by 2 minus dou phi by dt. But only thing is this is one is xyt you will get. The other one is p square by 2 minus dou phi by dou t function of, it is xzt. This is with respect to z if you do it integration. This is with respect to y. Right, so general format we obtained it. Actually the general format is if I now combining all these things, what can I observe is, so plus p by 2 plus v square by 2 minus dou phi by dt is equal to, finally it is only a function of time. Now if the flow is steady, if the flow is steady, then dou phi by dou t is equal to 0. Therefore, and at the same time, ft is also a constant. Therefore, psi plus p by rho plus v square by 2 is equal to constant. Now, this psi, what we have written, x is equal to minus dou psi by dou x, y is equal to minus dou psi by dou y, z is equal to minus dou psi by dou z. This is what we have taken. But here, the gravity force component means only weight, that is only in z direction. Therefore, minus dou force potential by dou x is equal to 0, minus dou force potential by dou y is equal to 0. There exists only minus dou force potential by dou z. This is equal to G. This is basically, actually, this is force potential per unit mass. So naturally, I have written, because this is represents only weight, and weight is equal to, mg, and per unit mass, if you are writing, it is G. So therefore, finally, minus d force potential B that is equal to G. Therefore, basically, because if I am taking it in the, if force potential basically normally in the positive direction of z axis I have taken, then it is minus G. So therefore, psi is equal to Gz plus C. So same thing if I substitute. So our equation is psi plus p by rho plus v square by 2 is equal to constant. Now if I substitute, it is gz plus p by rho plus v square by 2 is equal to constant. Gz plus constant, if I write also, it goes into that. So if I make it again, divide 2 out by g, z plus p by rho g plus v square by 2g is equal to constant. Or otherwise, p by gamma plus v square by 2g plus Z is equal to constant. This is what the Bernoulli's equation is. The same here, if I see, basically, this is the energy equation. This is the energy equation. Here, there are three terms. The first one, what is P by gamma? It is also called as pressure head, and this is also called as pressure energy. It is basically the pressure energy per unit weight of fluid. Per unit weight of fluid. Then V squared by 2g is called as velocity head, and it is called as kinetic energy per unit weight of fluid. Last one, Z is called as datum head. It is potential energy per unit weight of fluid. So each term of the Bernoulli's equation represents the energy per unit weight, pressure energy, kinetic energy, and the other one is the potential energy. So now if you apply the Bernoulli's equation basically, and finally I can write it as Bernoulli's equation is what? The sum of pressure head, velocity head, and datum head is constant. If you apply the Bernoulli points, then naturally it will be P1 by gamma plus V1 squared by 2g plus Z1 is equal to P2 by gamma plus V2 squared by 2z plus Z2. This is what the Bernoulli's equation is. If it is applicable between 2 points. What is the statement of the Bernoulli's equation actually? Bernoulli's equation states that in a steady, because this is one assumption we have made, in a steady irrotational flow of an incompressible fluid, because rho is constant, of an incompressible fluid, the total energy at any point is constant. What is the total energy? Total energy means it is sum of pressure head, velocity head plus datum head is constant. Then what is piezometric head? Piezometric head means it is P by gamma plus Z is called as piezometric head. Pressure head plus datum head. Now, what is the datum head actually? If you take the flow through a pipe which is horizontal, for example, this is the center line of the pump. If I call this as section 1 and this is section 2. So if you take a reference line, this from the center of the pipe to the reference line, this is called as reference line, and this is also called as datum line. Datum. So this is Z1 and this is Z2, right? So here again it is the pressure head P1, here pressure head P2, velocity V1, velocity V2. So now if you take it, if the pipeline is horizontal, if the pipeline is horizontal, then Z1 is equal to Z2. Therefore, if you apply Bernoulli's equation, it is P1 by gamma plus V1 squared by 2G plus Z1 is equal to P2 by gamma plus V2 squared by 2G plus Z2. As Z1 is equal to 0, both will cancel. That means is the datum head will not be there in the picture, will not be there if the pipeline is horizontal. But if you are finding total energy at a point, then total energy is equal to P by gamma plus V squared by 2G plus Z. That's all. Next, datum head plays datum head plays an important role if the pipeline is inclined or vertical. So here we stop this Bernoulli's equation, and now in the next class we will discuss some practical applications of Bernoulli's equations. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.